Assalamualaikum warahmatullahi wabarakatuh and good morning. Okay. In this video, we will start cover topic 4, which is on dynamics. And then if we refer to textbook, which is it is in chapter 12. In this chapter, we will cover from 12.1 until 12.6. Okay, for the first two video, we will cover rectilinear motions on continuous and erratic motions. Okay. In this subchapter, which is 12.1 until 12.2, students should be able to find the kinematics quantities, which is position, displacements, velocity, and accelerations for a system of particles that's traveling in a straight line. Okay, this is examples of an applications. We model a car like particles, and then from that we want to find out kinematics quantities, for example positions and velocity in any instant, for example. Okay, for the first half in mechanics, we have study about the statics. Then now we start study on the dynamics, which is includes kinematics and also kinetics. Okay, then whether you can read it, what is it the difference between kinematics and also the kinetics. Okay, for examples, if we consider a particles travels in a straight line, okay, then normally we define coordinate systems that known as s-axis. Okay, that's show that particles travels in certain distance in straight line. Okay, then we also can define the position vector, okay, for the particles when it travels in a certain distance. Then we can define a position vector, which is given by this vector r. Okay. Then we also can have a scalar quantity, which is known as s. Okay, then these scalar quantities can be positive or negative. Okay, then normally both of the quantities, which is the position vector r and also the s, the units are in the meter. Okay, then the other quantities also can be defined. For example, total distance travel, which is known as st. Okay. Okay, then second quantities, kinematic quantities, is velocities. Okay, then many types of velocities quantities can be found. For example, we can find out the average velocity. For example, the average velocity is defined as the difference in positions divided by the times elapsed, which is from, for examples, if the particle travel from point 1 to point P to point P prime, known as delta r, then the total times travels from these 2 points is delta t. Then we can find out the average velocity. And then secondly, we normally define the instantaneous velocity, which is the velocity at any times or any points. For examples, at p primes, at p, and then we can find out the vp prime, also vp. And then this instantaneous velocity also defines by this the derivative of r, which is positions of our particles, divided by the t, which is dt. We can also have a kinematics quantity in terms of scalar value, which is normally we call it as a speed, which is the speed is actually the magnitude of the velocity, which is ds over dt. Of course, we differentiate the ds, which is the scalar quantities of the travels distance by a particles over time. Then further, we also have accelerations as a kinematics quantities, okay, which is defined as the rate of change of velocity of particles. Okay. In a vector forms, we have a, which is accelerations a, which is the derivative of velocity, the velocity vector over time. And then for scalar, we have the same formula, but the difference is v is in terms of scalar value. And then further, as we defined previously, we consider as a scalar quantities for our positions, and then of course it will be double differentiations of s divided by dt squared. If we have the accelerations in a positive value, that means the velocity keep increasing, or if we have the accelerations in negative value, that means the speeds are decreasing. Okay, then the other important one is actually we can also find out the formula for velocity by using the relationship between the accelerations velocity, sorry, it's too big, between the velocity and accelerations by using this formula, which is actually we take from the velocity equations. For example, from the velocity equations, we have v equals to ds over dt. Okay, this is the first equation. Then secondly, we have the equations for the acceleration, which is a dv over dt. This is the second equations. Okay. To eliminate the variables times, which is t, that exists in that formula, which is we have dt over here and then this dt. Okay. By using some mathematical manipulations, we either we divide equation 1 divided by equations 2, okay, for examples. Then we have v divided by a is equals to ds over dt divided by dv over dt. Then of course we can cancel out dt terms here, and then if we manipulate the equation, then we should get these equations, which is ads equals to v dv. Okay, then this is the equations that relates the velocity and accelerations. Okay, for summary of this part, if we have velocity equation, which is actually the integrations of, sorry, the velocity, which is the differentiations of travel distance divided by time taken, which is ds over dt. And then we can also have the equations for accelerations is just equals to the derivative of velocity over time. And then also from the last equations that we derive, we have ads equals to v dv. Okay, then manipulate these equations, then you can have a is equals to v multiplied by the differentiations of v over distance s. Okay, then from the equations that we obtain here for velocity and accelerations, we can find out the velocity and also positions by integrating both accelerations and also velocity equations. Okay, for examples, okay, to get these equations, we integrate these equations, which is integrates dv equals to the integrations of a dt. Okay, then from v naught until v, and also from t naught until t, which is normally t naught is defined as times equals to 0. Or if we take from these equations, then we can have this integrations formula, which is integrations of v dv equals to integrations of a ds. Okay, which is, now we have ds, so we have from s naught until s. Okay, then for positions here, okay, we just integrate ds to get the positions. Okay, then it should equals to the integrations of v dt, which is v in terms of time t. Okay, that's for, or to get the velocity or accelerations, or to get the velocity and the positions from the integrations solutions. Okay, then if you consider a is constant, if we consider a is constant, okay, then we say that this is a special case, which is a constant. For examples, when particles move upwards or downwards due to the gravity accelerations. Okay, then the gravity the acceleration is equals to the gravity effect, which is 9.81. Okay, then because of this, okay, from the three integrations formula that we have, we can get we will obtain the formula for velocity is, if a is constant here, then v dv, of course, actually is equals to v minus v naught equals to, then this is 0 plus at, 0 plus at ac t. Okay, then if we solve it, then we can have v equals to v naught plus act. Okay, then secondly, from the integrations of ds equals to integrations of v dt, okay, then we have the velocity equations, this part, then replace this v with the equations for v that we have, which is equals to v naught plus act. Then if we integrate this part, okay, for integrations of ds, then we have these two terms. For the integrations of v naught act dt, then if we solve it, we will have this equation, which is v naught t plus half of act squared. Okay, then at last, okay, we have integrates v dv, and then also ac ds, and then of course because we don't have the velocity equations in terms of v, and then also the solutions equations in terms of s, then we can directly integrate these equations. Then we can have v squared, actually integrations of v, you should get v squared over 2 is equals to ac s, okay, where we have v naught and also v here, and then for here we have s naught and s. Okay, if we solve it, then we should get this equation or this formula, which is lastly equals to v squared equals to v naught squared, where v naught squared is the initial velocity, plus 2ac equal multiply s minus s naught. Okay, then this is the three formulas, the important formulas we can directly use if we have a special case here, which is the acceleration is constant, or the velocity increase in straight line. For example, if we have a graph here, which is, for example, this is t, then this is v. Okay, then we have this type equation, which is y equals to mx plus c. Then this is also when we have constant accelerations.